So look at the output here. So we first print the original message. This is the message, zeros and ones. So it's just computer message. But even this is not visible to the image, to the human eye. This is the image that has the localized watermark. Tell me if you can see any difference between these two images with your own naked eye. I don't think so. Don't blame your eye. Don't say you have side effect or side defect. No. That is how good the model has been created to work. Welcome to today's video. Today I have a very exciting news to share. I found something interesting online. I'm going to talk about watermark. Watermark. Not the watermark that you would usually think of. Hidden watermark. And this is very important when it comes to deep fake detection, because there has been a lot of work going on in recent years. I mean, from 2018 to now, you discover that a lot of interest has actually come off with the issue of deep fake detection because of what is happening around the world. There has been a lot of deep fakes that is aimed at creating misinformation and disinformation, and this can cause political chaos, economic meltdown. It can cause a lot of issues. It has been used in pornography, in many things. Many people's faces are manipulated with AI, to pass false narrative. So the effort to come up with solution that can be used to detect when an image, video, audio, or even text is AI generated or manipulated is absolutely crucial. And so in this video, I was researching on it and I found this technique, and I think this is a very useful thing, and I'm so excited about it. And hopefully you can you also be excited, because I think this work is really unique and it's recent. It's a new it's a new discovery basically, but this will help if it is adopted or backed up with policies. Every AI content created should be watermark. That is what I'm saying. And watermark, not like that is visible to the eye. No, I'm talking about hidden watermark, so that the physical eye cannot see, but AI model should be able to predict and use the watermark to tell if an image is original or fake. That is what I want to discuss about in this video, and I found this work online. You can also download it. You can also download the call app and try it yourself. The link is there, and it is publicly available for you to try and see what you can use of it. Oh, absolutely. This is not the first thing. This is not the last thing as well. This is just one of the steps that can be used towards detection of deep fakes. Because if every companies or all of these AI companies are mandated to embed these techniques into their products, then will be some. Well, I mean, I believe that will be towards some good progress, because that means every content created comes with a label that is not visible to the eye, so the image will still be good looking, perfect. You cannot detect with your eye, but our digital tools should be able to tell you whether it is AI created or it's an original image. And this is what I'm going to discuss in this video, and I'm really excited about this, and I'm looking forward to using this work, in our future project, to come up with some trust AI system. But for now, let me walk you through how you can use this, how you can run this notebook and use it for your work. I've just copied it from there, but this is the link. If you see this link here, you can copy it by all means, and then run it, and you'll be able to download the link. Basically, this is you can clone the repository, and yeah, you'll be good to go. Good to go. So I don't want to talk much, and I don't want to share a lot. I just want to focus on demonstrating this for you now. I'm not sure if this is okay, but let me increase my zoom to 200. Yes, and I see. Hopefully you can see better now. So the first thing I'm going to do is to clone the um, uh, the repository from GitHub, but I've already done that. So this is just going to be it's just going to show some message, but I did that and it worked. So I just want to show you guys that you can also do the same. Just that in this situation, it is going to be it is going to show me different message, and don't expect that message if you are running it for the first time. So let's go to clone. This is what you run, and you can see here. All right, because I haven't restarted my kernel. So everything, I restarted my session basically. So it connects and then we receive everything. So you should be able to see this message exactly. I'll first show you how to run this on Google Colab, and then I'll also show you how to run it locally on your machine using your Jupyter notebook. It also works fine. And I will show you with the original image that came with the model, and I'll also be able to show you how to use your own image or your media. But first of all, this is the work. Watermark anything with localized messages. So you pass any kind of message, but in this case, you can just pass a correct message that tells you what need to be what you want to pass through. Basically, you can customize the message. To be honest, this is what I'm trying to say. So now, yeah, I've cloned the model. At this point, I want to be able to go into the folder, download the dependencies, and the requirements is all here. So I'm just going to hit the run button and watch it do the job. Here now we go. And I am impressed because it's not that computative intensive, especially when you are running on the cloud. And this is the free tier of Google Colab, so I didn't pay for the extra storage, And it can use both GPU and CPU, as you will see later. Yeah, so the requirement now already met. Most of it are already satisfied. Yeah, this remark is there for you to use. You can use GPU, but I mean, it is recommended that you use GPU for best output. But if you don't have, obviously you can use CPU as well. Don't worry, you don't need to modify anything. The code is written in such a way that your modification, your system will work fine. Yeah, you can check out the GitHub as well. Like I said before, this is the link to the GitHub here, the repo. All you need to do is just copy from here, copy from this HTTP to this markup anything, and then open it online, and you'll be fine. Now, the next thing I would like to do is to progress with the demo. So here, I'm just going to go to the folder now. And now we're ready. So let's import the libraries. As you can see, most of these things you are familiar with. Then we're going to import some PyTorch libraries as well, as you are seeing there. And then this is the main thing. This is the watermark notebook that is created, which you want to use. So, and here is your device. You are going to check if there is GPU, then it's going to use CUDA. Otherwise, if it's not available, then it will use CPU, so that you don't have to edit the code. Well, if you have GPU, fantastic. If you don't have, it will still run on your own CPU. And yeah, here is a function to load the images, basically, that is defined here. And then here is a function to load the models as well. So let's run this cell and see. It will take some time. I mean, it will take a couple of seconds to do that, and it should be successful. Yes, that is done now. When I was doing it locally, it took longer than this, but yeah, you can see it's fast and okay, no problem. Now, the next thing, we want to create some seed, and for that, this is what is happening in this. The parameters are selected there. Image directory, number of images. We're only using 2 here, but by all means, you can use more than 2. Number of images to watermark from the folder, and I will show you the folder in a moment, in a bit. But yeah, that I just we'll just want to use 2 images from the folder, and the proportion to be marked, want to use 0.5%. That is proportion of the images to be watermarked, and like 50% basically of the image. This is for a reason. You can watermark you can set this to be 100%, but it's just like it means more work. And if you are working on a video, or maybe the image, if you have lots of images to watermark, then it could take, the processing time could be high. So yeah, you can as well reduce this to 40 or 30% if that is sufficient for your project. And yeah, so here now, this create the outputs here. So I'm just going to run this cell now, and that is done. Basically, it's not doing anything. It's just creating function and the rest. So not function actually, just setting some parameters, and yeah, just creating some variable that we'll use later on. Now we want to use one localized watermark per image. In this code here, I'm not going to take time to explain because it's going to take it will take our time. But leave a comment if you want me to explain this code line by line. But it doesn't. There are comments already within the code, and it is very simple to understand, easy to go, as you can see here. So I'm just going to run the cell, and then let's watch the output. So this is where it will take some time, but not even long as well. I'm really impressed with how this is created. It doesn't take time to load, but obviously when you now adapt this into your own project, coupled with what you are doing, it may now take longer time. But yeah, we always want to create that green code to consume less energy. So look at the output here. So we first print the original image that we want to hide in the code. This is the sorry, not the original image, the original message. This is the message, zeros and ones. So it's just computer message. But even this is not visible to the image, to the human eye. So this is the original image, as you can see, that comes from the developers, and this is the image that has the localized watermark. Tell me if you can see any difference between these two images with your own naked eye. I don't think so. Don't blame your eye. Don't say you have side effect or side defect. No. That is how good the model has been created to work. To hide the image, to hide the message, the watermark should be hidden. However, if you take the difference between the watermark image and the original image, you should be able to get this to tell you that yes, there are watermarks in the image. Look at it here now. So the next thing we want to look at is we want to create where we inserted the watermark, and look at it here. So you can see that this box created, this rectangle here, is also similar to what you are seeing in the difference here. And if you come down here, the predicted watermark is very close, very close. So the percentage is very high. And because it is expected that a different tool can be used to predict if there are watermarks or there is a watermark in a content or not. So this is the accuracy for this. And yeah, let me just go down for the second image. I said we are going to use two images. Again, so here we are predicting the message for the image. So one of the image in the folder is called dogs. And as you have seen here, as you have seen above, look at it here, you'll see there are dogs here now. Toy dogs maybe. But yeah, now this is the message that is embedded in it. And then the bit accuracy for this image dogs is 1%. So let's look at something. 0, 1, 0, 0, etc. 0, 1, 0, 0. So this message, the original message and the message that is predicted is exactly the same. 1, 0, 0. So we come here, I'm just trying to see 1, 0, 0, as you can see at the end here. So that's how accurate this message, this model, this guy. Now you see that here we have got the original image. So this is the second image now. We've got the original image here and the image with the watermark here. With the eye, you are hardly able to see anything. It's just the same thing. But look at the difference here. There is certainly a watermark here, but it's difficult to see. You cannot see this with your own naked eye. You can't see this with your naked eye. And let's look at the position of the watermark as it was created in the original image. And this is where it was predicted. So look at how close this thing looked like. Very, very close here. And I just want to go back and look at the message that was that we got from there. The predicted message is this 0, 1, and then ending with 0, 0, 1 again. And then, yeah, the accuracy is 1% because it's not overfitting or underfitting here, guys. It's just like the image, the message you got, it predicted is 100%. And that is obviously because we are the one that are imputing or creating the watermark. And at the same time, we're the one predicting it, so it should be doing very well. But obviously, maybe when you take it to a new data, freshly or non-unseen data, perhaps it will differ a little bit. But yeah, these are things that I believe that with good regulation and policies, we can combat deepfake effectively. So come to think of this now, we want to now, okay, this is the same thing basically. So I shouldn't have even run this. Because I wanted to use it to demonstrate with the local image, but with my images, because the other images I've been using comes from the developers. So you should be able to see the same output here. Basically the same thing that we've seen above. But now I would like to go on to talk about creating more than one watermark. So here we're talking about one watermark per image, quite a big one. Maybe this is not suitable for your kind of project and you want to create more than one watermark. We can actually do more than one. Basically, take this code and modify it, and you can create as many watermarks as possible. But yeah, we want to see how we can create two watermarks in one image. And this is the code again. You are seeing that you can see that we are using DBS scan here to create a cluster. Epsilon is 1. The minimum sample here is 500, and that is because the number of pixels in a 256 by 256 image, to form a cluster. I don't really want to explain the code, guys. Like I said, they've done a very good job by including comments for each line of code, so it's easy to understand. So this is the code. I'm just going to run and then wait. This should take a little longer than the first one because we're creating 2 watermarks per image. Remember, the first one was just 1. We're now creating 2 localized watermarks per image. Yes, that is done. It's pretty fast, to be honest. So yeah, let's look at the output here. Excuse me. Here we have the original image and the image with localized watermark, and that is the original message that we want to embed, but we're embedding two messages. See the first message, and this is the second message, and this is where we embedded the message. As you can see here, this is the difference. So we've got one down here and one here. Tell me that this is not impressive. That means I don't know what you're looking for. But yeah, here we come down here and we also look at the position, of the watermarks on the image. This on the watermark has we created, and this is has predicted by the model as well. And here we've got the cluster that is created using the DBS scan. Look at it here. How amazing is this? I'm not really going into technicality. I'm just excited about this. So I just want to share with you guys. And here, so the number of messages found in image docs 2. And then centroid, this is the centroid. The bit accuracy is 0.965, almost 100%. The Hamming distance between the two is 1/32. And yeah, for the other one we found the centroid again is that. Bit accuracy is this, and there's not a Hamming distance for the second watermark. So the same thing repeated here with the second image. And here you go. Just very similar thing. Look at the position of the watermarks here when you take the difference between the two images. And yeah, this is the created watermark, or position of the watermarks rather, and this is the predicted position of the watermarks. So you can see here there's a kind of overlapping here in the predicted result. Hence you will notice that there's a difference in the output, in the accuracy there, a little bit different. But bit accuracy is 1, bit accuracy is even 1. So yeah, well, I think that you will appreciate this because for me this is groundbreaking, to be honest, in the effect of detecting AI. So it's not really it's a innovative way of using this technology, because while it may not be a new technology, it is good that it is hidden. If it was not hidden, then it may spoil our own project. It may spoil the beauty of the image, but it is hidden, so that's good. And the second thing is that bad actors are also changing every day, so they may also start using watermark again. The question will be, if we create watermark and hide it within an image, and what if after manipulating they also create a watermark and hide it in the image, embed the watermark to say that yes, this is the original image, meanwhile it's not original image. That means we need to find some regulation around how these things work, but certainly this is a very good technology. So this is the same thing. I don't want to really run it. I just want to come down here. The last thing I want to talk about here is the one with segmentation. So we are using marks here. I will show you how the marks are created. They are all in this folder, but yeah, with segmentation marks. So let me run the code and see. Not really talking about how the code works per se. We are using the image docs here, as you can see here, from the marks actually. So let's look at the output. So look at this. You are now embedding not just message, but an image, marks image. Yeah. So look, original image. This is your original image, and then this is image with localized watermark. The watermark here now is not a text, but you're kind of embedding docs on the image, if that is what you want to do. Of course, this is visible, but do you know that you can still make this invisible? And when you look at the difference between the two images, look, this dog that is here and this guy that is here, we took them here, embed them on this image. So there are several ways you can apply these techniques, guy, in your projects, I believe. But this is the difference between the two images as well as it is obvious. These are the position of the watermarks, and this is the predicted position of the watermarks. Can see it, look very closely. And these are the clusters that were formed using our DBS scan parameters that we discussed before. And so the accuracy here is, for the second image is 87%, and for the first one is 81%. Not bad, but yeah, this is pretty good. Yeah, you can even work to improve this accuracy. Yeah, once you download the repo, you'll be able to see everything. Don't worry, this is just a set that I was showing a message. So now the most important part, I want to go into the folder. This is the folder here. I will see the images are here, as you can see here. If you want to use your own image, once you come to the watermarking anything under the asset, just get rid of these images and then put your image. Or you can just add your images and then maybe make it force the model to use your image by actually declaring the name of the image. But I would like to delete the images that are there for now. Remember, this is the one I'm playing with now. It's a copy that I downloaded. It's not actually the original one. So the original, when you receive, if you do go and download, you're going to see the original one. Let's delete this again. I'm just deleting the images, and that is it. The C background, and there's also text. We didn't use this as well. So now I want to upload my own images from my local machine. On the folder, I will just select this option, upload. These are my images, so I'm going to import 3 different images, or perhaps let me start with 2 images because I don't want it to go and confuse me. If your image is too heavy, then it may take time to load. So I really compressed these images to just few kilobytes. The images were originally in megabytes, like 13 megabytes. I have to compress it down to just 21 megabytes to make it easy for this work. But think about if you want to also compress your own, or you want to leave the same. So yeah, I'm going to open this. Now these images are downloaded here, uploaded, sorry. So I'm going to close the folder again, and I'll go all the way up to where we started. I'm not going to load the libraries again because obviously my session is still active. I only need to load the libraries if my session has stopped or has started. For now, yes, even this, I don't need to run this, obviously, because I'm not loading the image from here. Yes, define message, print this, and then iterate over the image, or iterate over each image in the directory. Yes, so I will start from this cell, because I don't want to waste your time. I don't want it to be too long. I don't want the video to be too long. Good. So now I've used my own image. Look at that. Just look at that. Uh-oh, what's happening? So this is the image. This is the original image, guys, without watermark. This is the image with watermark. See where my watermark is inserted here. The watermark is embedded here. Again, it's not visible to the human eye. So this very location here, this empty space even, there's a watermark there. Just so that if you want to perform some image analysis or anything, the watermark should not really interrupt your image more. So the model pick out an empty space within the image and then insert the watermark there. Obviously, you can reduce this size as well, but see, the watermark is somewhere here, which is obviously an empty space. You know where the computers and the tables are. The watermark is not there. It's actually here, even though it is still invisible. Now let's look at the position we created. Look at it there. And then this is the predicted position. This is accurate. This must be 100%, I believe. Yeah, 100%. And that's the message that is embedded there. You can see that the message is changing because we are generating random message, but you can customize this message. I didn't explain the bit of that, the bit of the code that is doing that, but yeah, this is the message that is in the first image. Now the second image is this. This is our original image, and this is the image with localized watermark. Very interesting. So the difference between the watermark, the difference between the original and the localized watermark image is this. As you can see here, so it's not separating actually everything here because some background of the original image is left behind the watermark. So it's now considering that this is also part of the watermark, or so I don't know, part of the message. As you can see here, them is cut, and then even this white background also there, but nevertheless, this is still a very good work. Our own idea was that we want to embed hidden watermark in our own in any content, whether it's manipulated or it's still brand new, so that will help. And there are a lot of questions that people can ask, but yeah, we should. This is the kind of ongoing research that we need to talk more about it. Here we have the position of the watermark created, and this is the predicted position. You can see it looks very much alike, and the accuracy is 97%. I was even thinking it's going to be higher than this. And that is the message. If you check, the messages are the same, because the message that we use for the first image is also used for the second image, since the messages were not just generated once. And now, well, this is the same thing, so I'm not going to run this one. This is still the original one I run before, so I'm going to leave that. I will come down to the two localized watermark per image, two localized watermarks per image. So I'm going to run this cell so that we see what will come from there. Because there are two watermarks, so it's taking a little bit longer. But imagine if you are using more than one, if I want to include more than one watermarks or more, like we say here, the message that we're generating, we are just declaring two. You can change this number to anything, but just know that more watermarks may mean more processing time, and if your images are of high resolution, you also need more processing time as well. Yeah, but let's look at our output. This is our output here. Two watermarks per image. This is the image without watermark. This is the image with watermark. Absolutely, except you are saying that I have side defects. Otherwise, there is no difference. If you never have to zoom this, if you never zoom this to 250 or whatever, you will see that there is no difference between them. Look at it there. But I will just reduce it to 200 again, just so that it's easy for you to scroll through. And look at the position here. This is taller than this, and this is wider than that. And then we have feet here as well. And then, yeah, these are the messages. 93%. How many distance here is 2. I'm not really focused on, I don't want to really go into explaining what all of this mean, like the bit accuracy, how that is computed, the centroid, and etc. But yeah, this is how it is for the first image, and this is how it is for the second image. Watermark image, no watermark image, the same. This is where it chooses to place the watermarks, one up here and one down here. Yes. And then, yeah, so we now have the position here as we created and the position here as predicted, very closely alike, and even the DBS scan that created the clusters. Look at it here. This is so amazing. This is awesome. The number of messages found in image 2, small, you see, because I changed it. That's the name of the image. So in image 2, small, dot .jpeg is 2. Yes. And the bit accuracy is 1. Bit accuracy here is still 1. How many distance? 0. All right. The third one here. Yes, I don't want to run this one because I need to change the name of the image, either to dogs or something. But yeah, this will not work. This will behave differently. But that is it. This is how you can use the model on Colab, Google Colab. I will quickly want to show you how to do it locally. You can download it to your system and then use it. So I'm using a MacBook. You see that cloning directory? You can copy it and then just paste it into your terminal in a directory that you want, and then run it. It will download it. Let me show you my terminal if I can. This is my terminal. So this is my terminal. I installed everything. Okay, it has been messed up because I was installing a lot of stuff here. But yeah, let me just leave that for you guys. I'll quickly show you how to run it on Jupyter Notebook. If you do need help with downloading or cloning it locally, then let me know. But by any means, I just want to show you how this works on how to run this locally. So these are the images. I'm not going to, again, you just need to copy the image to the location. For instance, this is my This is my, yes, this is my folder. Let me change the view for you guys. So you can see I added my images here, and I'll first run with the original image. So one challenge, I'm using MacBook, and funny enough, Apple doesn't. Apple, this is MacBook Pro. I have 48 gig RAM. In fact, I'm using Apple M3 chip, but still, it doesn't support GPU, as you guys will know. So in as much as the system is good, I'm disappointed because there's no GPU. So if you are running on the CPU, it keeps collapsing, it keeps failing, and this is the challenge. If we have money, we can acquire much bigger system with GPU, and then we'll try this on high dimensional or high definition images and even videos, and do some kind of complicated work with it. But yeah, it refused. So let me show you how it works here on my local machine. I ran it before. So, oh no, not that. I want to see if I can zoom this a little bit. Yes. Now I have zoomed it. Can I make it 200? 200? Okay. It's not 200 yet, isn't it? But I think this is visible. So, similar thing to what I did. Let me just restart my kernel so that it clears everything. Actually, I want to restart my kernel and then also. Don't take time, please. Please, it's taking long. Okay, it has done it. I want to restart kernel and clear all output. Yeah. Good. Now it has been done, so there's no more output again. I want to run through it quickly. This all this information are there for you to read. This is the link again. So I'm just going to run it, but in this case, because I'm running it locally, it will say I have already done this before. So let's do it. So it gave me a kind of fatal message. It said destination path, this already exists and is not an empty directory. So if I want to use this in an empty directory, I need to go to a different directory. But the directory I'm using here is this. As you can see here, I'm already in the directory here, so the watermark already exists. Now, yeah, so I'm just going to run through it. Now I want to go into the folder, pip install requirement. Possibly it should tell me that all of this I've already done because I have done it before. But it's downloading the checkpoints is very important. Yes. You know, pip install the requirements.txt. That is going to say all of the requirement has already been made because I literally ran this not long ago from now, before now. But now I have it. Now I have, yeah, the main important part is that it downloaded the checkpoints, it updated the checkpoints, which I absolutely needed for this model to work. And so yeah, I will come down here. This is only for Colab, so I'm going to skip that. Let me just import the libraries now. Hopefully everything goes fine. It will take some time to import them because I'm now running it locally. But I will wait. Let's see how long this takes. While this is running, I will be singing a song. But I think I just wanted to look at this and let me know what you think. If you encounter any error, well, try to run this either locally on the Google Cloud, let me know. On Colab, let me know. And leave a comment, let me know what you think and what project are you going to be using this for. So we have, yes, so now it's just the same cell basically. So I'm just running through it. Now, as you can see, there is no output yet, so I'm going to run. And this is the only one that will probably work. Yes, this works with the original image that came with. So this is the original image. This is the image with the watermark, and this is where it's created. This is the original created position of the watermark. This is the predicted watermark position. We've got predicted message is this, same of course, and the accuracy is 100%. The second image, you just flip here. This image now came second. Similar thing that we saw before. Watermark is here, the position is here, this here. Look at it here. Then, yeah, that is it. That is it, guys. So let's try to see. Let me tell you the problem I'm encountering. It doesn't just run on my CPU. So if I do next, now I want to try with 2 watermarks per image. Look at what you see. I've encountered error before. If it doesn't, you see that. Say kernel restarting. The kernel appears to have died. It will restart automatically, and this never restart. So I'm going to restart this just so that I can demonstrate locally with my own image as well. So restart kernel and clear output. I will go into the directory and delete all the other images. Oops. I wanted to show you guys how I'm deleting it, but yeah, it's trying to take time now. So I will just come here. I will delete all the images except this. I want to use this. So let's move all of this to the bin. Now I have done it. So since I've restarted my image, I will need to go back to the beginning again. I will just start running from here again so that we can see that boring message again. Then I will go down, change into the directory, and then I'm importing the checkpoints which is needed for the model. And then yeah, I will go down to, yes, like I said, this is just for the collab, so I don't need it here for the model to work. And I will import the libraries as well. It will take time again, but I just left one image. Oh my god, I should have left two images there. I just left one image. Let me see how it works. Yes, I've only inserted images, so bear with me. I'm just going to drop another image there. Image, and I'm in this time around I'm going to use a different image. Probably I should use an AI generated image. Yes, let's try to use an AI generated image. I will drop it into the directory. Sorry, you're not seeing my screen at this point in time. What is the size? I just want to make sure it's not too heavy. Okay, 85 kilobyte, that should be fine. Okay, now it's time to load the, okay, let's continue now. Let's create our seed, set this variable. Now we want to do it on the image. Let's create a watermark. The other image I'm using is an AI generated image, and the other image is original image. Let's see how this will look like. Yes, so this is the original image. You've seen this a few times already. Now this is how it works. Uh-oh. I was working in the wrong directory then, because it still picked the images that I used before. Anyway, but this is now running locally. I think I'm in the wrong directory. Yeah, I thought this is the image. Just give me one moment. If I can locate where the images are, and I can as well check here. This is the images are in this folder called asset, and in asset folder you go to images. Oh, sorry. Yes, these are the images that are there. This is the image I was about to use, but unfortunately, this guy is giving me a different image. I don't know. This image is no longer in the directory. Wow. Okay, I think I will go back because I'm pretty sure this is the directory. Yes. Yes. So I will go back, not from the library per se, but maybe from, yeah. Okay, let's go to the library. Can somebody tell me what I did wrong? Okay, so I will restart kernel, clear output, and then start all over. Please, I'm waiting for the kernel to be clear. Alright, so I'm going to start here. Okay, this is probably where I should have started. Checkpoints, watermark, anything. Yes, maybe. Probably this is where I needed to start. I'm not even commenting on the import requirement. This is for this. So let's import our model now. I'm expecting the second image to change. It should be an AI generated image and not the original image that was in the folder. Even the other image I put there is no longer taking it, so I don't know why. But let me just check. I'll be with you guys shortly. Alright. Okay, so we go one localized image. Now let's see it. What do you have there? Ah, so definitely there's something that I'm not doing right. I finally lost the directory. But look at here, this is where I am. These are the images. AI generated image and AI generated image and this is a small image and then AI generated image. This is what I'm using basically. And in our marks image we have dogs. This is just for the marks that were created to use. Oh, sorry, same image. Yeah, dogs 1 and dogs 2. And the asset is splash.1. You can see this is from 3 hours ago. This was created. It's not even that I'm running this. 4 minutes ago. This is surprising. This is where the notebooks are. So by the way, when you download the folder, if you want to run it locally, this is the Colab. The what is named the Colab. That's what you need to use to run locally. I just close that, and then I go with this. Where are you getting the images from? Yeah, I don't need that actually. Ah, okay. I will figure out what I'm not doing wrong, whether I'm working in a wrong directory. I don't know. But this is the same directory. It keeps giving me the image that I've already used. Huh. And if I run the next one, it will say kernel is dying, you see. Okay, I think this makes sense, guys. So I will leave the link to the notebook in the comment section and you will find more information. Not the notebook, basically, the GitHub repository, so that you can find more information on the license, which is allowed for public use as long as you give credit to the creators and pass the link or to others, which is what I'm doing. And yeah, you read the 2 different license for yourself. I think there's also a paper that you can read and understand how the work is done detailedly. But from my end, I want to say bye bye now. You can see that cloud is the deal, so we need sponsor for this kind of project if we want to really take it forward and do something interesting out of this. But at this point, thank you and have a wonderful evening.